Okay, so what this is saying is if they you have the same base on both sides of the equals, okay, b and b, then you can set the exponents equal to each other. If the bases are the same, then you can set x equals y equals to each other. So like in this problem, we have the same bases, right? Both 5. So in order to solve for the exponent, we can ignore the bases and just set the exponents equal to each other. Right? So 2x plus 4 equals 5x minus 8. Right? Because we have the same base. Right? It has to be the same for this rule to work. Okay? If they're not the same, I'm going to show you a different way to do it. Okay? But then we'll just go ahead and solve. Okay? So we're solving for x. What do you want to do first? Minus 2. Okay, I'm going to do minus 2x. You could have also done minus 5x. I like to do the smaller number first. Okay, if at all possible. So that brings down my 4, 5x minus 2x, 3x, and bring down my minus 8. And then what? We're at plus 8 first. Plus 8 first. Okay, 4 plus 8. 12 equals 3x. Now what, Kevin? Now divide, right? 12 divided by 3, 4. Okay, now I know that was a slightly longer problem than we've seen recently, okay? But also, think about it. Do you think that I could take shortcuts if I wanted to, me, Mrs. Carr?
Yes.
Right, yes, I could, right? But I don't, because I'm showing you the best way to do it. Also, look how clearly I wrote everything, right? I didn't take any shortcuts. I wrote it really clear so I don't get mixed up, because half the time I see students make mistakes, it's when they did something kind of sloppy, okay? Or they tried to take a shortcut. And that's not the point of this. We're trying to get the problem right, okay? So just don't try to take shortcuts. You'll be fine. You'll make it if you write it all the way out. I'm going to write it out in all 6 of my classes, okay? So you only have to do it once. Right, so everybody see what we did? You with me? All right, any questions on this one?
No.
All right, I want you to do the next one on your own. Okay, number 2. 7 to the 5x minus 2 equals 7 to the 3x plus 4. Okay, first thing you want to ask yourself is, do they have the same base? Do they? They do, right? So when that happens, we can just ignore the bases and bring down the rest of the problem. Okay, 5x minus 2 equals 3x plus 4. All right, okay, now I want you to continue solving this one. I'm going to come around and check your answers, okay?
Look at the base. You add the base.
Right, since we're just trying to solve for x, right, you don't have to have a base in the answer at all. Okay, because you just want to know what x is, since x is in the exponent on both of these. It's okay, you don't need to.
Wow.
All right, almost there.
For real.
Right, solving it.
I know.
Move the, I would minus 3x. All right, what are we getting? 3, right? X equals 3. That's what I got too. Okay. All right, if you did not, double check yourself. You did 3 equals x or x equals 3. If I didn't get to you, it doesn't mean I don't love you. Okay, it just means I passed you. Okay, but I get x equals 3. Right, and yeah, Kevin was just asking, well, we don't have to worry about the base. On this one, we're just looking for x. So in our answer, you're just going to have x equals. Okay, doesn't. But if you plug it back in up here, 5 times 3 would be 15 minus 2 would be 7 to the 12th power. Right, or, no, sorry, 7 to the 13th power. Right, and then here, 3 times 3 is 9, plus 4 would be 13. That would be 7 to the 13th power equals 7 to the 13th power. Okay, so it would still be equal if you plug it in and check it. Okay, so let's try number 3. Okay, 4 to the 2x minus 1 equals 8 to the x plus 2.
You can multiply by 2.
Right. Not exactly, but I see where you're going with that, and you are on the right track that you want to fix it, right? What's the problem with this one that's different from number 1 and 2? The bases are not the same, right? This rule only works if the bases are the same. However, right, we can use rules of exponents to find a common base, okay? And I'll always give you ones that it's easy to see. These are both, you could use a common base with an exponent to get to it. What would the common base be between 4 and 8?
4.
Right, well, 4, yeah, exactly. 4, because 4 squared would be 16. That would pass up 8, right? 4 with an exponent